All right, so in this last video, dealing with limits as x is approaching either positive or negative infinity, I just want to highlight the connection between these types of limits and horizontal asymptotes. And then I want to take a look at the limit as x approaches plus or minus infinity of some of the other functions that we are familiar with, such as e to the x and so forth. So first, the connection with horizontal asymptotes. So let's say I've got a function which maybe looks something like this. All right, so this function that I've drawn has two horizontal asymptotes. Let's say, for instance, maybe this line here is y equals L1. And this line here, let's say, is maybe y equals L2. Then from the picture, we could say the limit as x approaches negative infinity of this function f of x is equal to L1, because as x moves further and further to the left, this function moves closer and closer to the y value of L1. And similarly, we could say that the limit as x approaches infinity of this function would be L2, because as x moves further and further to the right, the function is approaching the y value of L2. So these limits, where x is approaching positive or negative infinity, are going to tell you what the horizontal asymptotes of your function are. More precisely, we can say that the line y equals L is a horizontal asymptote of some function f of x if and only if either the limit as x approaches negative infinity of f of x is equal to L, or perhaps the limit as x goes to infinity of f of x is equal to L. And then if you are given a function and you want to find its horizontal asymptotes, whether it has any, the way to do that would be to evaluate these two limits. And whatever answer you get will tell you if a function had any horizontal asymptotes and what they were. So as some examples, we had this function from the last video. F of x was the square root of 3x squared minus x plus 2 over 5x minus 4. And for this function, we found that the limit as x approaches plus or minus infinity, it was plus or minus root 3 over 5. The limit was root 3 over 5 when x was approaching positive infinity, and the limit was negative root 3 over 5 when x was approaching negative infinity. So therefore, we can conclude that y equals root 3 over 5 and y equals negative root 3 over 5. These are the horizontal asymptotes of this function f of x. Okay, so now I just want to take a look at some of the other important functions that we work with. Let's start with the function f of x equals e to the x, the exponential function. So the graph of e to the x looks something like this. And from the graph, we can see that the limit as x approaches negative infinity of e to the x. So here, as x is moving further and further to the left, e to the x gets closer and closer to 0. And the limit as x approaches infinity of e to the x. In the picture, you can see as x moves further and further to the right, e to the x will just shoot upwards towards infinity. So from these two limits, you can sort of read them as saying e to the negative infinity would be equal to 0 for the first one. And for the second one, you can sort of read it as saying e to the infinity is infinity. And then finally, this function has one horizontal asymptote at y equals 0. And that's reflected in the fact that this limit was equal to 0. And because this limit was infinite, that's why we did not have a second horizontal asymptote. Okay? If we consider a trig function next, let's just take a look at sine. All right, so remember the graph of sine looks something like this. And really it just sort of oscillates back and forth between -1 and 1 forever and ever. If you take out the limit, take a look at the limit as x is approaching either infinity or negative infinity. Regardless of which one you're looking at, as x moves further and further to the right, now sine of x is not really approaching any single value. Rather, it just keeps oscillating back and forth, never approaching a single value. So because of that, this limit would not exist. And same for the limit as x goes to negative infinity. And so because neither of these limits exist, you can see that this function has no horizontal asymptotes, and that's pretty clear when you look at the graph. It will be a similar story for cosine as well. Next, let's maybe take a look at the natural log function. Okay. So the graph of the natural log function looks something like this. The first thing to maybe note is the limit as x approaches negative infinity doesn't even make sense. Because the domain of the natural log function, it's only defined for positive x values. So it's not even possible to consider x approaching negative infinity for the natural log function. But more important to note is what's happening as x is approaching positive infinity. So as x approaches positive infinity, it's a little bit hard to see, but the natural log function, it does grow without bound. So as x moves further and further to the right, the natural log function is going to slowly but surely shoot up towards positive infinity. Okay, so this limit is infinite. And from this limit, you can sort of say that the natural log of infinity is infinity. All right. I'm not going to cover all of the functions that we look at or that we commonly use, but I'm going to look at just one more, which is the function f of x equals the arctangent of x. So the graph of the arctangent function looks something like this. And it has these horizontal asymptotes at pi over 2 and negative pi over 2. So because of those horizontal asymptotes, we have that the limit as x goes to infinity of the arctangent of x, you can see from the graph that that limit is pi over 2. And similarly, if you take the limit as x approaches negative infinity, you can see from the graph that arctangent is going to approach negative pi over 2. And from these two limits, you can sort of imagine saying that arctangent of infinity would equal pi over 2 then. And that similarly, arctangent of negative infinity can be considered as minus pi over 2. Okay? All right, but that's all I'm going to do for this video. So this would be the last video on limits as x is approaching positive or negative infinity. Thanks for watching.